All right, let's dive in. Today, we are pulling back the curtain on one of Java's most powerful, maybe even secret features. It's the thing that separates those slow, clunky apps from the ones that feel lightning fast and responsive. We are talking about the art of multi-threading. Oh, you know that feeling, right? You click on something and boom, nothing. You're just stuck staring at that spinning wheel of death, that little rainbow pinwheel just mocking you. Your entire application is completely locked up, and all you can do is just sit there and wait. It is so frustrating. Well, there's a really good reason why that happens.
I want you to imagine a super busy restaurant kitchen, but there's only one cook trying to do absolutely everything. I mean, they're taking the orders, chopping the veggies, grilling the steaks, washing the dishes, and trying to plate dessert, all one after the other. So while they're stuck trying to get a complicated sauce just right, new orders are just piling up, and the customers, they're left waiting and getting angry. The whole kitchen just grinds to a halt. That right there is exactly what a single-threaded application is doing to your computer.
So this is where multi-threading swoops in to save the day. It's basically the programming version of hiring a whole team of cooks. Instead of one poor person doing everything in a line, you've got a whole crew. One chef can be chopping veggies while another is on the grill, and a third is getting the dessert ready, all at the same time in the same kitchen. It's all about doing more all at once.
Okay, so here's where it gets really cool. Each one of these cooks, or threads as we call them, has its own distinct life cycle. It's just like a shift at work. They don't just pop into existence and then vanish. Nope, they go through a whole series of specific states from the moment they're created until their job is totally done.
Let's just walk through it real quick. So first, a thread is new. Think of it like this. Our chef is hired, they've got their uniform on, but they haven't clocked in for their shift yet. Then they become runnable. They're in the kitchen, apron on, ready to go, just waiting for an open cooking station. Once the CPU gives them a job, they're running. They are actively cooking. But sometimes they have to go into a waiting or blocked state. Maybe they're waiting for the oven to heat up or for another chef to pass them the salt. And finally, once their task is complete, the thread is dead. Shift's over, they've gone home for the night.
So, if we want to build this awesome kitchen crew, how do we actually do it in Java? Well, it turns out there are two main ways to hire your threads. You can think of it as the difference between hiring a specialist versus hiring a generalist who just happens to know a specific skill.
Okay, so on one hand, you can hire a specialist. This is where your code is a thread. It's a specialized employee, inheriting all the things that make a thread a thread. On the other hand, you can hire a generalist. This is just a regular employee who knows how to do a cooking task. They aren't a thread themselves, but you can hand them a recipe or runnable task and then assign them to a generic thread worker to get the job done.
Now, the specialist approach, where you extend the thread class, is super direct. As you can see right here, you just create an instance of your special thread class, myThread, and you just call start on it. That's it. The object itself is the worker. Simple.
Now, the generalist approach, using runnable, has one extra step. See that? First, you create the task, the recipe itself. Then, you hire a generic worker. That's the new thread part. And you hand that recipe to the worker. Then you tell that worker to start. It's a little more flexible because it separates the worker from the work itself.
Okay, so we've hired our team. The kitchen is buzzing. Cooks are working all at once. But wait, this creates a brand new problem. With so much going on, how do you stop it from becoming total chaos? You know, how do you keep your cooks from literally bumping into each other or fighting over the same spatula? You need rules. You need kitchen rules.
This question gets right to the heart of the biggest challenge in multi-threading. Just picture it. There's only one really good chef's knife in the whole kitchen. What happens when two different cooks both reach for it at the exact same time? I mean, one of them might get it, but the other one is stuck waiting. And if they don't coordinate, well, in programming, that's called data corruption. In our kitchen, that's a trip to the emergency room.
And the official solution to this problem is a concept called synchronization. Really, it's just a fancy word for having a system to control how multiple threads get to use a shared thing, whether that's our special knife, or a file on the computer, or a variable in memory. It's all about making sure things happen in an orderly, predictable way.
In Java, you often do this with the synchronized keyword. You can literally think of it as putting a lock on a tool. When a cook needs that special knife, they lock it. Now, nobody else can use it, not until they are completely finished and they unlock it. This totally prevents those conflicts and makes sure the job gets done right without anyone interfering. So, locking solves the problem of sharing tools. That's great. But what happens when the cooks need to actually cooperate with each other? What if one chef is waiting for another one to finish a sauce before they can finish their own dish? They can't just stand around waiting forever. They need to be able to, talk to each other.
And that's exactly what this is called, inter-thread communication. Just like in a real kitchen, you can't be efficient without coordination. You hear chefs yelling things like, "Sauce is ready all the time, right?" Well, in Java, our threads need a way to send those same kinds of signals to each other, to say, "Hey, I'm waiting for something," or "Shh, that thing you were waiting for, it's ready now."
Let's use an example to see exactly how this works. Imagine a cook needs 15,000 sprinkles for a huge cake, but the shared sprinkle bowl only has 10,000. They can't move forward, so they call wait. This basically puts their task on pause and tells the system, hey, wake me up when there are more sprinkles. Meanwhile, another cook comes by and adds 10,000 more sprinkles to the bowl. After they do that, they call notify. This sends a signal out, waking up the first cook, saying, hey, the sprinkles are here. The first cook can now wake up, take the sprinkles they need, and finally finish their cake. That, in a nutshell, is wait and notify.
So we've hired a team, we've made some rules, and we've even taught them how to communicate with each other. Let's just take a step back and look at the big picture here. Why go through all this trouble? What's the real payoff of having this well-oiled, multi-threaded kitchen?
So what's the big payoff? Well, first, you save a ton of time because so many things are happening at once. Second, your whole application is way more resilient. If one cook messes up and burns the dish, the entire restaurant doesn't shut down, right? The other cooks keep working. And finally, you get this incredible efficiency. Your computer's processor is never just sitting around bored when there's work to be done. And what does all of this mean for you, the person actually using the app? It means no more freezing. It means an application that feels buttery smooth and responsive. It can handle complicated stuff in the background, like downloading a huge file, without ever interrupting what you're trying to do. It's the secret sauce for building truly powerful software. So we've seen how Java's multi-threading can turn a potentially chaotic kitchen into a fine-tuned machine. It's all about taking one huge, overwhelming job and breaking it down so a team of coordinated specialists can tackle it together. So the question I want to leave you with is this. Now that you know how the kitchen works, what complex, amazing meal are you going to cook up next?